Hi, abstraction, that's the concept we are trying to understand in this lecture. We saw about integers, int, float, etc. And we saw that int, float, etc. had operations like addition, multiplication, right? On the other hand, we don't know how int, float, etc. are stored. I never explained to you how a float number is stored, right? I just told you that it takes some 4 bytes, but not how it's represented, how these bits are represented. But we can use those functions, addition, multiplication, etc. This is the concept of abstraction. And in the sense, the machine is hiding you all this information, the information regarding how how the addition, multiplication, etc. work is hidden from you, is abstracted out from you, right? That's what abstraction is doing. And as a programmer, you can use this addition, multiplication, etc. without knowing any of this. You don't have to know whether how addition is implemented or multiplication is implemented to use that fact. And that's why I have always told you, when you write function, you have to write its input and you have to write it out. You have to write what is its output going to be. And as the person who wrote the function, you have to ensure that for all this input, your output is going to be correct. Why? Because you will learn to write things in an abstract, your mentality is going to be to write functions as an abstract entity. What is the reason for this? Then the next time someone is going to access your function, someone is going to use your function. Let's say you wrote a function, let me just call it func, func, and you wrote a function which takes as input maybe 2 integers, int x, int y, and you return an int. And you are saying that, okay, if you this function is, let's say, going to square the number and return. So sum of square. So it's going to return x square plus y square. Now, when you say that, so this is so it's going to take both integers and return an integer. Okay. And now, when you say that, you are guaranteeing to anyone who is going to use this function that it's going to return the sum of squares of x and y. The person who is going to call, let's say from the main, someone called from the main the same function with 10 and 20, he does not have to know how x square plus y square was implemented. This is the idea of abstraction. Okay, he is just told what this function is going to do, and he does not have to know what is inside. Right, only the input and output. This is the way it's going to work. Only the important things which this guy has to know, which the main programmer has to know, only the thing which he needs to know is what is the input and what is the output, and the function when you have written, you have ensured that that's what you do, and that's exact. So the two things, this function does what it tells it does, that is, it's going to return x square and y square. Second thing is that it does only that, it does not do anything more than that. It's not going to print anything because it does not say that it's going to print. So it won't print anything, right? So you need to guarantee that, and that's the idea of abstraction. And then you when you write programs, you need to write like that. And in this lecture, we have seen abstraction, the idea of abstraction using function, where different functionalities you make it as functions and then use that. So this is an idea. The idea of abstraction happens in all everyday life, and if you have to understand a lot of concepts, you abstract out a lot of details. You try to understand only what is required for you to understand, and that's how you can build on things. For example, if there are a lot of computer scientists who work on, let's say, DNA profiling, and DNAs are massive objects. For a computer scientist, you can think of DNAs as just a string, as a word, okay, or an alphabet of the atomic components of the DNA, okay, ACGT, right? And on the other hand, what these things are, all biology people are looking at, right? So they have abstracted out into these ACGT, the letters of the DNA, and now computer scientists can work with those strings, right? Words over ACGT. Now you have already taken the biology course, right? So you understand these things. Now, so that's one level of abstraction you do. So similarly, if you are going to work in other fields, for example, you are going to abstract out those. You don't want to look at. You want to only take those information which you are going to work on, and that's abstraction, right? And even here, during the course of the lecture, I abstracted out many details of many things. I didn't tell you how memory is managed, right? How memory is allocated or not freed, etc. I just gave you a brief idea, but the main idea is that I have abstracted out. It's part of a different course. That's going to be covered in a different lecture by in an operating systems course. Those things will be covered. How memory is allocated, for example. Now, or a compilers course, how memory is allocated in here. So these things will be covered by a different course. I'm just pointing you to those directions. But as far as our course is concerned, I have abstracted out. I am just taking out only those information which I need for this course, right? That's the idea. Thank you.